Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime Series 25, Episode 101, for broadcast on the 26th of September 2022. Coming up on SpaceTime, bad weather scrubs a third launch attempt for the world's most powerful rocket, and when it does fly, one of the spacecraft on board will be NASA's IceCube mission. And Virgin announces plans to launch orbital rockets from Queensland in 2024. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
In a case of déjà vu all over again, NASA has been forced to scrub a third launch attempt for its massive Artemis 1 moon rocket, this time because of Tropical Storm Ian near Jamaica, which is forecast to rapidly intensify as it moves towards the Florida coast. Over the weekend, NASA officials decided to forego Tuesday's launch window and began preparations to roll the world's most powerful rocket back from Space Launch Complex 39B and into the Vehicle Assembly Building at the Kennedy Space Center. If the rollback goes ahead, the next launch window on October 4th will be missed, forcing mission managers to wait until new launch windows open between October the 17th and 31st. The massive 98-metre-tall Space Launch System, or SLS moon rocket, had just completed a successful wet test of its trouble-plagued liquid hydrogen fuel line system. The first launch attempt back on August the 30th was scrubbed following persistent liquid hydrogen leaks in the launch pad's umbilical quick disconnect fuel line system, which had already been plaguing the mission during earlier wet tests. Other technical difficulties involved an 11-minute communications delay between the spacecraft and ground control, and a crack in the insulating foam on the connection joints between the liquid hydrogen and liquid oxygen tanks. Most troublesome, however, for that first launch attempt was an apparent coolant bleed issue with one of the 4 former Space Shuttle RS-25 main engines which are used on the SLS core stage. Mission managers seemed unable to chill down the number 3 engine. Now, this is normally done by opening bleed valves in the main engines, which feeds cryogenic liquid hydrogen through a web of pipes in the engine in order to chill it down. However, the bleed valve on the number 3 engine apparently refused to open properly. Mission Control tried increasing the pressure on the main tank and closing the valves in the other 3 main engines, but they still couldn't get enough flow through the problem engine. It was only later, after the mission had already been scrubbed, that technicians traced the problem to a faulty sensor rather than any issue with the valve itself. But then a second launch attempt on September the 3rd was scrubbed following another liquid hydrogen fuel supply leak. This one developed in a different part of the arm connecting to the engine section, and it was far more serious than the earlier leak. NASA decided to tackle the problem at the launch pad rather than roll the giant rocket back into the Vehicle Assembly Building. Technicians replaced 2 seals in the troublesome system, and another wet test was then carried out, during which the cryogenically cooled liquid hydrogen and liquid oxygen were fed into the rocket and then successfully cycled out again, with only a minor hydrogen leak developing, which was quickly resolved by adjusting the pressure in the feed. Launch Director Charlie Blackwell-Thompson told NASA TV she was pleased with the results.
Well, I think the test went really well. We went into this test. We wanted to learn. We wanted to evaluate the TSMU, the LH2 TSMU under cryogenic conditions, understanding that we had done both an 8-inch and a 4-inch seal removal and replacement out of the pad. And we got into our loading operations. We had a new loading procedure that we had in place. It was very purposeful in the way in which we went through the loading ops. We wanted to be We called it kinder, gentler, where we really monitored the temperatures and the pressures across the interface. And once we got into what we call our fast fill operations, we did notice as the pressure came up that we did see a leak in the plate cavity at the 8-inch QD. We went through our pre-plan. We have utilized it a couple of times where we stop flow and we allow it to warm up, and then we reinitiate. When we reinitiated flow, we began to raise the pressures back up to get back into a fast fill configuration, and we were successful in that. So we did not see the same leak signature, which was wonderful. It allowed us to go through our loading profile all the way to core stage replenish. We also loaded the upper stage as well, went through our kickstart bleed, went through our pre-press test. So all of the objectives that we set out to do, we were able to accomplish.
And it was impressive just to watch and take in and listen to the engineers as they work through those leaks. Again, just impressive work. I wonder what your thoughts are on these seals, which, as you mentioned, were replaced. You're learning a lot. There's a lot of data yet to look at. What are your early thoughts about how they're behaving and what a path forward might be?
Well, I think you got to always take the data and go look at what it tells you. One of the pieces of data very encouraging to me was as we raised the pressure, we actually saw the leak go down. And,
on the 8-inch QD.
Yes.
Yep.
And so this is a pressure seal, pressure-assisted seal. So that was very encouraging. And then, we saw the leak rate really taper off. So we'll go take all the data from this event, the early data, the data all the way through loading, through our pre-press tests. The engineers and the team will go take a close look at that and evaluate what we learned. And then we'll certainly be applying that as we get ready for launch. We'll take the data and we'll go see what it tells us. I am extremely encouraged by the test, getting through all the objectives, and we're setting up in our scrub turnaround to begin replenishment ops in preparation. I don't like to get ahead of the data, and so I'd like the team to have the opportunity to go look at it to see if there are changes we need to make to our loading procedure, our timelines, or if we're good as is. But I'd like the team to have an opportunity to look at that before I speculate.
And last question on the team itself. As we encountered that first leak, you could kind of feel the room deflate just a little bit. And then as they worked it and got past it, there was a lifting, so to speak, of the room. Talk about kind of what you went through when you were observing this and what you saw your team and how they reacted.
Well, I'm really proud of the team. I think they reacted well. You're going to be disappointed when you see a leak, and I think that's normal. But what they did is they went and looked at what are our contingency procedures, what do we have in place, how do we work our way through it, and they went through those ops just as I would expect them to do, and we were successful in managing our way through it. And you're right, as we began to see that those contingency procedures were successful, certainly there was a lift within the room, but I couldn't be more proud of the team and the work that they did.
It's now been 11 years since the launch of Atlantis on the last space shuttle mission, STS-135, which flew from neighbouring Pad 39A way back on July the 8th, 2011. It's also been 50 years, that's half a century, since the launch of Apollo 17 on what ended up being the last manned mission to the surface of the moon. That lifted off on December the 7th, 1972, also from the neighbouring Pad 39A. When it does finally fly, the unmanned Artemis 1 mission will undertake a 6-week journey to the moon and back. Its massive core stage and twin solid rocket boosters, all based on space shuttle technology, providing the immense power needed to lift the 2,609-ton behemoth into low Earth orbit. After an initial orbit around the Earth, during which the spacecraft's perigee will gradually be increased, the interim cryogenic propulsion stage will undertake a 20-minute main engine burn, placing the spacecraft on a trans-lunar injection trajectory. The now spent interim cryogenic propulsion stage will then be jettisoned from the Orion spacecraft, after which it'll deploy 7 of the 10 cubesats it's carrying, which will undertake a range of different scientific research projects. As the Orion spacecraft travels towards the Moon, the interim cryogenic propulsion stage will follow behind, orbiting once around the Moon before being flung off into deep space. During its journey to the Moon, the spent stage will deploy another 2 cubesats and then deploy the final cubesat as it loops around the Moon before heading off into deep space. Meanwhile, Orion will undertake a series of carefully choreographed orbits around the Moon, adjusting courses needed and getting to within 100 kilometres of the lunar surface before flying off on a distant lunar retrograde orbit, more than 60,000 kilometres from the lunar surface. That's further than any human-capable spacecraft has ever travelled before. After completing 1 or 2 distant lunar retrograde orbits, Orion will undertake a return powered flyby burn to send it back towards the Earth, or at least where the Earth will be when Orion gets to that location in space. On its return leg, Orion will make a series of course adjustments in order to achieve the exact Earth entry interface to re-enter the planet's atmosphere at some 40,000 kilometers per hour. That's faster than any other human-rated spacecraft ever. It'll eventually splash down in the North Pacific Ocean, where US Navy recovery ships will be waiting. NASA says the rather leisurely outbound journey should take between 8 and 14 days. That compares to the just 19 hours it takes to cover the Earth-Moon distance on a typical mission to Mars or beyond. But then again, those missions don't need to slow down to enter lunar orbit. Still, the manned Apollo missions only took 3 days to travel from the Earth to lunar orbit, so this will be a relaxed timetable. Plenty of time for science and for testing spacecraft equipment. NASA says the distant lunar retrograde orbit will take between 6 and 19 days, and another 9 to 19 days has been set aside for the return journey to Earth. If all goes well, Artemis 2, the first mission carrying humans, should launch sometime in 2024. And that hopefully will be followed in 2025 by the first mission to return humans to the lunar surface. This is SpaceTime. Still to come, NASA's tiny Lunar IceCube undertaking a big mission, and Virgin says it'll launch an orbital mission from Queensland in 2024. All that and more still to come on SpaceTime. NASA's water-scouting Lunar IceCube mission might be small in size, but it will have a huge impact on lunar science, searching for water hidden in dark shadows and deep craters on the lunar surface. The satellite is attached to the upper stage of the unmanned Artemis 1 SLS moon rocket mission. It'll be deployed together with 9 other satellites hitching a ride to the moon. Once in orbit around the moon, Lunar IceCube will use a spectrometer to investigate lunar ice. Earlier missions have already revealed loads of water ice on the moon, but Lunar IceCube will further NASA's knowledge about lunar ice dynamics. See, scientists are interested in the absorption and release rates of water from the regolith, that is the moon's rocky and dusty surface. With Lunar IceCube investigating this process, NASA can map these changes as they occur. Lunar IceCube will also study the lunar exosphere. That's a very thin layer of gas and dust, too thin to be called an atmosphere, which hovers just above the lunar surface. By understanding the dynamics of water and other substances on the moon, scientists will be able to predict seasonal changes for lunar ice that could impact its use as a resource in the future. The 14-kilogram Lunar IceCube, along with future Artemis missions, will increase science's knowledge and understanding for living and working on the moon and eventually on Mars. This report from NASA TV.
As the Artemis missions journey to the moon, finding and understanding water will be key to establishing a renewed presence there. Water is critical to life and can be broken into hydrogen and oxygen, which can serve as rocket fuel. The Lunar IceCube mission, led by Morehead State University, will carry a NASA instrument called BIRCHES to investigate water ice on the moon. Lunar IceCube is a small satellite designed to provide observations at diverse lunar regions to better understand the moon's water cycle. NASA scientists will use Birch's data to understand where water is, what its origins are, and how we can use it. Birch's will also help map water in the exosphere, an extremely thin volume of atmosphere surrounding the moon. Scientists are interested in understanding the absorption and release of water in the moon's regolith, dust and rocks on the lunar surface. This research will help scientists and engineers better understand changes to water on the moon over time. Birch's uses a similar technology that flew on the OSIRIS-REx mission, which studied the asteroid Bennu. However, Birch's has been miniaturized to 1/6 the mass of the instrument on OSIRIS-REx and is roughly the size of an 8-inch tissue box. The Lunar IceCube spacecraft and Birch's instrument will launch as a secondary payload on the Artemis 1 mission, helping pave the way for future crewed exploration missions to the lunar surface.
This is SpaceTime. Still to come, Virgin Orbit to launch from Queensland, and later in the science report, researchers have created what they say is a living synthetic cell. All that and more still to come on SpaceTime. The rural Queensland city of Toowoomba could become a future spaceport for Virgin Orbit. Virgin's just signed a memorandum of understanding with Australian infrastructure development company Wagner Corporation to use their Toowoomba Wellcamp Airport as a local base of operations. Virgin says that, pending approval, it'll begin flying from Toowoomba in 2024. Virgin launches satellites into orbit using a modified Boeing 747-400 airliner, nicknamed Cosmic Girl, to drop launch its own two-stage rocket called Launcher 1, which is released from a cradle under the port wing of the airliner next to the fuselage, a hardpoint originally designed to transport spare jet engines. The 21-metre-tall Launcher 1 is released at around 35,000 feet. It carries small satellite payloads up to 500 kilograms into low Earth orbit and up to 300 kilograms into sun-synchronous orbits. Launcher 1's existing 5 flights have all seen Cosmic Girl take off from the Mojave Air and Spaceport near Los Angeles and then drop launch Launcher 1 over the Pacific Ocean. Its next flight, which is slated for next month, will take off from Spaceport Cornwall, located on the grounds of the Newquay Airport in Cornwall, where the UK Space Agency have set aside a hangar to house the Launcher 1 rocket and a clean room for handling payloads. Future UK plans include having the rockets manufactured on site rather than transported from the US, and setting up a mission control centre to direct at least 3 missions a year. Meanwhile, here in Australia, Toowoomba was selected because of its 2,870-metre-long runway, which is rated Code E, being long, wide and strong enough to handle aircraft the size and weight of a Boeing 747. Following the 2024 Toowoomba launch, Virgin says it plans to develop a fully operational facility at Toowoomba Airport by 2027. Last year, Virgin announced a similar deal with the Brazilian Space Agency to use their Alcantara launch centre, which is just 2 degrees south of the equator, allowing launches to almost every orbital inclination. Astronomers have discovered 32 new variable stars in the Palomar 2 globular cluster 100,000 light-years away in the constellation Auriga the Charioteer. The newly found variables detected by the Indian Astronomical Observatory are mostly RR Lyra stars and cluster members. The discoveries, reported on the pre-press physics website archive.org, could offer important hints into aspects of stellar structure and evolution. Variable stars are useful in that they help astronomers better understand the cosmic distance scale of the universe. RR Lyra variables are powerful tools for studying the morphology, metallicity and age of galaxies, especially those with low surface brightness. Globular clusters are ancient stellar spheres, usually containing several thousand to several million stars, all tightly bound together by gravity. Many globular clusters are composed of stars which were all originally formed at the same time in the same molecular gas and dust cloud. Others, however, appear to be the surviving cores of ancient galaxies that have been cannibalized by other galaxies through galactic mergers. Globular clusters are commonly found in the halo of galaxies. Our own galaxy, the Milky Way, has at least 150 globular clusters, while our neighbouring big galaxy Andromeda has an estimated 500. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. Scientists have created what they claim is a living synthetic cell by harvesting bacteria for body parts. A report in the journal Nature claims the artificially constructed cell performs several key functions of a living cell, including generating energy and expressing genes. Researchers from the University of Bristol used 2 bacterial colonies for the body parts. The bacteria membranes were burst open using a lysosine enzyme and a honeybee venom polypeptide. The various organelles were then captured to create membrane-coated protocells, which were shown to be capable of complex processing, such as the production of the energy storage molecule ATP through glycolysis and the transcription and translation of genes. Gradually, over a period of 48 hours, the cell transformed itself from a sphere shape into a more amoeba-like structure, suggesting that its proto-cytoskeletal filaments were working. An extremely rare Judean coin, minted by Jewish rebels fighting the Roman Empire some 2,000 years ago, has been returned to the Israeli Antiquities Authority at an official ceremony in New York. The coin, known as the Year 4 quarter shekel, is one of only 4 such coins known to have survived from the Great Jewish Revolt against Roman rule that began in the year 66 and raged over 7 years, ultimately resulting in the sacking and burning of the Second Jewish Temple on Temple Mount in Jerusalem in the year 70. The coin was unearthed at an archaeological dig site in the Ila Valley, but it was looted by thieves and smuggled through Jordan to the UK, where it turned up at a London auction house in 2017. US Homeland Security officials finally seized the coin later that year after collectors tried to sell it at another auction, this one in Denver, Colorado. The Manhattan District Attorney's Antiquities Trafficking Unit returned the coin to the Israeli Antiquities Authority at a special ceremony at the DA's office in New York. Israel's ambassador to the United Nations, Gilad Erdan, told officials at the ceremony that the return of ancient Jewish archaeological artifacts is especially important now as Palestinians try to rewrite the history of Israel and erase over 3,500 years of Jewish connection to the land. The minting of silver coins by Jews during Roman rule was considered an act of sovereignty and a declaration of independence from the Roman Empire. As the rebellion against the empire worsened, Rome responded by crushing the Jews and taking the last surviving members from their homes, dispersing them across the 4 corners of the empire, and renaming their traditional Judean homeland Palestinian Syria. While most Australians still trace their ancestry to England or at least the British Isles, a new study shows that medieval Brits weren't as British as they thought. A report in the journal Nature has found that mass immigration into Britain from Germany, the Netherlands and Denmark during what's become known as the Anglo-Saxon period may have increased European ancestry in the British Isles by up to 76%. The findings suggest that migrants influenced the formation of early medieval British society. We already know that English has a primarily Germanic background with a little bit of French thrown in after the Norman conquest. The study's authors examined archaeological data and ancient DNA from some 460 medieval people dated between the years 200 and 1300 across northwestern Europe, including 278 from England. They noted an increase in continental northern European DNA in the people from early medieval England, closely related to the early medieval and current DNA of Germans and Danish people. In fact, the DNA shows that Eastern English people were just 24% English and 76% continental European at the time. And even today, scientists say, a substantial northern continental ancestry remains, although it's been diluted by subsequent migrations from other parts of Europe, such as France. A new study has found that if you're rich and influential, you're far more likely to be selected as a target by a cult. Researchers found that cults often target the best and brightest, looking for wealthy and connected movers and shakers such as celebrities, doctors and government officials who can add to their influence as well as finances and power. And it's not just money and control. Sex also plays a big role in many cults. While most people think they're far too clever to be fooled into joining a cult, good con artists manage to suck enough of them in to become very wealthy. And once you're in a cult, subtle brainwashing, peer group pressure, intimidation, blackmail and outright threats keeps you in line. But not all cults are religious. Pyramid schemes are a form of cults as well, one based on money. But regardless of their motives, Tim Mendham from Australian Skeptics says cults all seem to follow a very similar pattern.
There's a whole lot of issues about the sort of people that are attracted or that the people who run the cults are trying to attract to their groups. And obviously the people who have money is one thing because it helps the cult sort of get a big cash pile to do things. It's also people who are looking for some sort of control in their life, something to make it sort of stable, if you like, their life, if they're feeling pretty sort of not sure of where they're going in life. Someone comes along and says, I can do it for you, I can look after you and help you out. They will jump at that. So there are obviously people with some particular psychological or personal hole in their lives that they need to fill, and these cults are more than happy to offer them things. There are people you would think would not be inclined to join cults, people who are fairly well educated, but as the skeptics find, education is no defence against any particular weird or paranormal belief, especially if you have an emotional attachment. And in this particular case, if you look at the general checklist of the characteristics of a cult, the first few that are always raised indicates the sort of people who might need to join a cult and what they get out with it. But the number one characteristic of a cult is it's always focused on a person, a living leader who's perhaps a bit charismatic, a good
Charles
talker.
Manson type, David Koresh.
Charles Manson, Jim Jones, all sorts of people who can have the gift of the gab. They're a salesman in a way, and they're selling this particular cultish philosophy. And the followers then display their extremely zealous and unquestioning commitment. And what happens is that this cult leader, when he gives the directions, the people have to follow it. And that's one of the key characteristics as well. Members follow this person's direction simply because he's so impressive. He or she might claim, although most of them are men, he or she might say that they're getting their instructions from God or wherever, and therefore they have to be followed religiously by the cult members. The cult is obviously designed to bring in new members. That's the key thing. So they're always out there proselytizing their particular activities because they need new blood all the time. They are preoccupied with making money. They want people with money, and that tends to be more educated people. And anything which is questioning, or if you have any doubt or you're dissenting, you're definitely discouraged from doing that and punished if you are, even to being thrown out.
Is that what differentiates a cult from religion?
Yeah, I think that what happens all the time is that the religions tend to sort of try and talk to you. And if you have any doubts, they will explain. This is basically out and out 100%. If you express any sort of doubt, that's it. There's no sort of discussion about it. You either follow or you don't. What often happens is that the person who doesn't gets thrown out and without their family or anything. So they're left out without any sort of family support or anything. The family might stay within the cult and the individual gets thrown out, which is if you meet people who have been through that, it's a horrible thing. And I have met people who have been through that, and they're quite sad cases in many instances. So the cults, the basic number one is if you've got a leader who is charismatic and a salesman and demands total obedience, then you got yourself a cult. Whether it's a religious-based thing or whether it's, some money-making scheme, you've got that sort of thing, and it's sort of pretty much a cult. And the reason people join them, because they need that stability, they need that certainty, perhaps, that someone's telling them what to do. So even if you are educated or well-financed, whatever, which makes you a good target for these things, you are just as prone to joining them as anyone else. Perhaps even more prone because you're probably more of a target.
And you think that you're too smart to be conned by something like that.
But the cults will always push the idea that we're better, we're different, we're sort of separate with the bulk of the population here because we are part of this elite group, and they have an exalted status, and that makes them feel better too, if they're better than the ordinary run-of-the-mill, the mug punter out there who doesn't have this wisdom that's being given to the cult members. It's a sad situation, but it happens all the time.
It crops up a lot in skepticism, doesn't it, where people think they've got special knowledge and that makes them better.
You have to think about skepticism as basically critical thinking, right? That's what skepticism is all about. Skepticism is not the answer, it's the way to think, right? And we're not going to tell you what to think, but we tell you at least try to think, and this is a good way of assessing the evidence.
That's Tim Mendham from Australian Skeptics. that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.